Today's video is going to be a short one because we're going to do a review in class. We want to be able to practice what we'll see on tomorrow's quiz. We're going to be looking at ways to represent data in tables, in mapping, in a list of ordered pairs, and we could also talk about graphs. I'm starting this first problem by giving you a set of ordered pairs. You want to list them into the table as well as represent them in mapping. So as you look at this data, you're going to put your X values, remember these are your X's and your Y's. X values will go in the first column, followed by your Y's. Now let's take that and put that into mapping. You only need to write each one once. You only need, as I said, to write each value once, and then in the second you put the range values, and then you'll map them by showing a correspondence. 5 goes to 2, 7 goes to 3, 9 goes to 3, and 9 goes to 4. Remember, a relation is a function if every input has exactly one output. This is not a function. And if you had to state a reason why it's not a function, because the input value of 9 has two different outputs. And remember, every input can only have one output in a function. It goes to 3, goes to 4. Let's list the domain. The domain is also my input. Remember these words, or my X values. If I had to list them, it would be 5, 7, and 9. My range is my output, and again, I'm just highlighting that important vocabulary that I could ask on the quiz. It's also my Y values, and those would be 2, 3, and 4. Again, you only need to list them once. So part of what we're hoping to accomplish in this lesson is to look at representing data in tables, either through ordered pairs, through mapping, or a table of values. A second set of problem, just to see another, would be the following. So looking at this set of data, again, I'm going to first represent it in a table, the X values and the Y values, the input and the output, the domain and the range. I keep using these words so that they really start to set in your head. All right, so let's set this up as mapping now. I have 2, 3, 4, and 5 as my domain. My range is 4, 5, 6, and 7. 2 goes to 4, 3 to 5, 4 pairs with 6, and 5 pairs with 7. Every input value has exactly one output value. This represents a function. Because, and again, if they ask you for a reason, because every input has exactly one output. And that tells you that you can distinguish between a relation and a function. From there, we also did some graphing. I'm not asking you to do any graphing or look at any vertical line test on this particular assessment. I will ask you a couple of questions about function notation. Remember, the equation form of this is y is equal to 8x minus 6. We change it to function notation by replacing y with f of x. If I want to find a value of y at a given x, I just replace that into the expression and simplify. So when I input 3, I output 18. Let's just see one more in our review. We're going to find this function is now a quadratic function. We're going to evaluate it at 5. We'll have 5 squared minus 2 times 5. That's the rule. The rule says to square 5. 5 times 5 is 25. 2 times 5 is 10. The result is 15. So when we input 5, we output 15. And there is your function notation. There's more to do with function notation than just this. That's all we're going to cover in our course. So once again, we'll review a little more in class quiz next time.